Welcome to video number 4 for Unit 3. This one is about setting up and solving proportions. So remember, VIC stands for very important concepts and that we're going to be working on for the next few days. So a proportion, that's in red, our vocab word, is an equation that states two ratios are equal. So we're going to be talking about setting up and solving proportions, such as the ones you see here. So remember, a ratio just relates a number to a number. So this is an example of a ratio, and this is an example of a ratio. So proportions say that these two things are equal to each other. So for example, if we had a problem that said something like, there are 15 males and 4 females, and then they give you a problem that says there's 450 males, how many females would there be? So here's an example of how you can set up that proportion if you're trying to solve for the number of females. Notice that I've got to make sure that things match. There's 15 males for every 4 females, so there's a matching here. And there's 450 males for X females. So notice I've got it matching up and down. I've also got it matching this way too. There's males across from males and females across from females. Now that's not the only way to set up this proportion. This is another example of a way I could set it up. I could set it up also as 4 females over X females is equal to 15 males over 450 males. So notice I've got females over females. It matches up and down, or vertically. It also matches horizontally. There are 4 females for every 15 males, and there's X females for every 450 males. So these are 2 correct ways to set it up, but notice I have to make sure that it matches up and down and across. Okay, testing a proportion. There's a couple of different ways to test to see if a proportion is true, or in other words, we're testing to see if 2 ratios are equal to each other. So one of those ways is cross products that you probably learned about last year. So cross products, remember product means to multiply, means I'm going to actually multiply across. So 5 times 16 and 7 times 12. Okay, so when I multiply those, if I multiply 5 times 16, I get 80. And 7 times 12, I get 84. These are 2 different numbers. That means that this is not a proportion. These 2 ratios are not equal to each other. We can also test the same proportion by using scale factor. So scale factor tells me what I need to multiply one to get to the other, meaning 12 times what gives me 16. We're going to talk about strategies about how you can get that number, but the main focus right now is 12 times what is 16. So I can do that by doing 16 divided by 12, and if I do that, I'm going to get 1 1/3. Well, if this is my scale factor on the bottom, if this is a true proportion, I should multiply 5 times 1 1/3 and get 7. Well, we saw that it's not true. The scale factor for the top is 1.4. So if these scale factors are not the same, that proves that it is not proportional. Okay, here's another example of how to test a proportion. So again, cross products and scale factor. Let's talk a little bit about that again. If I do 8 times 18 and 12 times 12, if this is a true proportion, I should get the same number. And I do. If I multiply 8 times 18 I get 144. And if I multiply 12 times 12, I also get 144. Same test for scale factor. For scale factor, again, I'm looking for 12 times what is equal to 18. And I can do that by doing 18 divided by 12, which equals 1.5. That means my scale factor is times 1.5. And if this is a true proportion, I should get the same thing here. So I can do 12 divided by 8. And I also get 1.5. So same process, but this shows you that this is one that is actually true. Okay, one more example, guys, and this one is a little bit tougher because you're going to see that the numbers are not all pretty. They're not integers. We've got 17.6, which makes it a little more tricky. We're going to do it the same way, though. So cross products, if I do 5 times 17.6 and 8 times 11, I should get the same number either way if it is a true proportion. So 5 times 17.6 gives me 88, and 8 times 11 also gives me 88. Okay, for our scale factor, again, doesn't matter if I start at the top or the bottom. What matters is that I get the same scale factor. So let's start with our numerators this time. If I do 11 divided by 5, I get a scale factor of 2.2. That means if I'm going to go from 5 to 11, I would multiply times 2.2. If I do 17.6 divided by 8, I should get the same scale factor, and I do 2.2. So that tells me that this is a proportional relationship. Okay, let's also talk today about solving a proportion, meaning you've got to set it up and also solve it as well. So here's a word problem that may help us visualize this. You have a recipe that serves 5 people, and it needs 2 cups of flour. You are serving 12 people. How much flour do you need? Please make sure, guys, that you use labels when you're setting up a proportion, because it's going to be important, just like we saw with the males, females, that it matches up and down and right to left. So let's set it up. Again, there's more than one right way to set it up, but here's one way to set it up. I could put 5 people, I'm going to use P for people, on the top. Well, 5 people need 2 cups of flour to make the recipe, so I'm going to put 2C for 2 cups. When I decide to put the 12 people somewhere, I'm going to have to make sure that it matches. So 12 people has to go on the top because I've got people on the other side on the numerator. So here's my X. I'm solving for cups of flour. There's a couple of different ways to solve here, guys. We're going to be focusing first on using scale factor. So that means I'm trying to figure out 5 times what would give me 12. To do that, I'm going to do 12 divided by 5, and I'm going to get 2.4. So again, this is my scale factor. I'm going to use that 2.4 scale factor to help me figure out what my X is. So 2 times 2.4 is going to help me solve for X. So 2 times 2.4 equals 4.8. So that means X equals 4.8 cups.